Okay, sequences and series. A sequence is a list of terms. Okay, it behaves much like a function, which is what I have highlighted here. F of x equals 4x minus 1. Okay, so I could give you an nth term formula. That's something that you'll hear me say a lot. An nth term formula that says a sub n equals 4n minus 1. That is saying the exact same thing as f of x equals 4x minus 1. So they behave in much of the same way. So if I want to find f of 1 here, that's just like saying I want to find a sub 1. That means plug in the value of 1. So if I plug in the value of 1 here for this x, I get 4 times 1, which is 4, minus 1, which gives me an output of 3. Okay. Same thing. If I just want to find f of 2 in this function f of x, I'm going to plug in the value of 2. That's the same thing as saying find a sub 2. I plug in the value of 2. 4 times 2 is 8, minus 1. That gives me 7. Okay. Go ahead and find f of 3 and f of 4 by plugging in 3 or 4. Okay, when I plug in 3, that's the same thing as saying find a sub 3, the third term. 4 times 3 is 12, minus 1, which is 11. When I find a sub 4, or f of 4, saying find the fourth term, I plug in 4, I get 4 times 4, which is 16, minus 1, which gives me 15. Okay. Notice, all of the values that I plugged in, those are positive integers. I plugged in a positive 1, a positive 2, a positive 3, a positive 4. And I got out values of 3, 7, 11, 15. So my domain was those positive integers. My output, the 3, 7, 11, 15, that is actually my sequence. Okay? So my sequence becomes 3, 7, 11, 15. Change that to the number 7 there. 3, 7, 11, and 15. Okay? The first term, a sub 1, is 3. The second term, a sub 2, is 7, so on and so forth. Okay, calculator procedures. Yes, we get to use our calculator for this whole chapter. There will be no calculator and non-calculator portion. I know you're smiling. I wish I could see you. Okay, so here is where we will find some critical pieces of information in our calculator under the Math button or the Stat button. We'll hit Math or we will hit Second Stat. Okay, so for my first example here, example A, I'm going to try to find the first 5 terms of a sub n equals n factorial over 2n. Again, that's the same thing like a function. A sub n is the nth term formula, and it's represented by n factorial over 2 times n, which just means I'm going to plug in the value of 1 or 2 or 3 in there for n. So if I just want to do this by hand, I could find the first term, a sub 1, by plugging in the value of 1 for n. So I would have 1 factorial, that's that exclamation point, it's called a factorial, divided by 2 times n, which in this case is 1. Okay. 1 factorial is just 1 over 2 times 1, which is 2. So my first term, a sub 1, in this sequence is 1/2. Okay. Comma. Let's find the second term. In order to find a sub 2, I'm going to plug in the value of 2. So I'm going to have 2 factorial, again that's that exclamation point, it's red factorial, over 2 times the n value, and in this case I'm finding the second term, so my n value is 2. 2 factorial is the same thing as 2 times 1, so it's 2, over 2 times 2, which is 4, which simplifies, again, to give me a 1/2. That doesn't hardly ever happen. So my second term here is also 1/2. Okay. To find my third term, fourth term, and fifth term, I can plug in 3, 4, or 5, respectively, or I can use my calculator, and I'm looking at the sequence buttons here. Okay, right here, the sequence. Okay. So here in my calculator, I want to follow sequence, expression, comma, variable, comma, lower bound, comma, upper bound. I'm not finding the sum right now. I'm only finding the sequence. So I don't need to write the sum in my calculator first. Let's go to our calculator. Pull mine up while you get yours out. Hopefully you have yours out already. And I need to turn mine on. Okay, locate where the stat button is, because we'll need to use the stat button, and locate where the math button is, because we'll need to use that also. The first thing that I want to do here in my calculator is make it say the word sequence, okay, because in this formula here, I need the word sequence, S-E-Q is what's going to pop up. Okay, to get it to say sequence, S-E-Q, I'm going to have to go to second, stat, arrow over to ops, and grab the number 5. So let's see what that looks on our calculator. I have second, stat. I'm going to arrow over to the word ops here, and I want to go down to the number 5 to get my sequence button. My calculator says sequence of what? What does it want the sequence? It wants the expression. In this case, my expression is n factorial over 2n. So in my calculator, I don't have an n, but I have this variable x here. So x factorial, go to the math, arrow over until we reach probability, and number 4 will give us that exclamation, which is the factorial button. Divided by, I want my whole denominator to say 2n, so I need to put it in parentheses. 2, and we'll use x instead of n. So 2x goes in parentheses. Next, I need a comma, which is located right above the 7 here, so a comma. And then it wants me to know what variable I'm evaluating for the variable x, comma, which is above the 7. Lower bound, I'm starting with a sub 1, so I'm going to use the value 1. And I'm going all the way into the 5th term. So, comma, upper bound is 5, close parenthesis. So this is saying, find the sequence of this expression, x factorial over 2x, evaluated at x, going through the terms 1 all the way into the term 5. So 1, 2, 3, 4, and 5. Hit enter. Okay, we don't want decimals, so let's go ahead and use our calculator to turn it back into a fraction, even though we already know those 0.5s are 1/2. Math, number 1, we'll turn it back into a fraction. So I have 1/2, 1/2, 1, 3, 12. We already know the 1/2, 1/2. Let's go ahead and write the 1, 3, 12. Okay. That is our sequence, 1/2, 1/2, 1, 3, 12. That represents the first term, I plugged in 1. The second term, I plugged in 2. The third term, I could plug in 3. The fourth term, I could plug in 4. And the 5th term, I could plug in 5. Okay, now it wants us to use the table feature of our calculator. Okay, in our calculator, the table feature is located with the graph. Okay. Well, I need to be able to find a graph first. My graph comes from the function. Remember, the sequence here, a sub n, the nth term formula is the same thing as a function. So I'm going to put this all into my calculator. 2x times x plus 1 times x plus 2 into my y equals button. 2x times x plus 1 times x plus 2. Okay, and I want the table, so I'm going to go to second graph to pull up the table. The table tells me for my first term, plugging in the value 1, I will get an output of 12. So my first term is 12. 2, my second term, I will get an output of 48. So my second term is 48. Go ahead and take a second to write down all 10 of those terms, starting at 1 all the way up until 10. So I end up with, you should be copying this from your calculator, I end up with 12, 48, 120, 240, so on and so forth. My pen is being so slow. If you can see my face right now, I'm very frustrated with it. Anyway, moving on to the next example, example C, I want to find a sub 12 for this nth term formula, a sub n equals 2n squared minus 3. Okay? If I want to find the 12th term, that's saying I want to let the n value here be 12. I want to find a sub 12. So I'm going to let n be 12. So into my nth term formula, I'm going to have 4 times the value of 12 over 2 times the value of 12, which is being squared, and then subtract 3. Go ahead and calculate that. 4 times 12 is 48. 2 times 12 squared minus 3 gives me 285. Trying to find a number that comes out of both of those, or use your calculator and turn it into a fraction, we get the simplified form of 16/95. Okay, example D here in this first section. I want to find the next 4 terms of this recursive sequence. So this is very weird, the way that this is written out. This is an nth term formula, but it's a recursive formula, which means the next term, k plus 1, is found by taking the prior term, a sub k. So I know that my first term is 4. If I want to find a sub 2, my next term, I want this k plus 1 to say the value 2. Well, in order for that to happen, k would have to equal 1 in order to have 1 plus 1 be 2. Okay, so here, this k value is going to say, I'm taking 2 and multiplying it to a sub 1, because I'm allowing k to be 1, and then I'm going to add on 3. So to find a sub 2, I'm going to take 2 times a sub 1, which is the first term here that's given to be 4. So 2 times 4 plus 3. 2 times 4 is 8. Add on 3, we get 11. Okay. To find a sub 3, okay, so if I want this to say 3, I need this k plus 1 here to say 3. So this time k is not going to equal 1. In order for this to say 3, k plus 1 equals 3. My k value is going to have to be 2. So into this k value here, I'm going to be plugging in 2. So I'm calculating 2 times a sub k, but we're letting our k value here be 2, so a sub 2 and then I'm going to add on 3. So I'm going to calculate 2 times a sub 2. We found the a sub 2 to be the value of 11. So I'm taking 2 times 11, and then I'm adding 3 onto it. 2 times 11 is 22. Add on 3, I get to 25. Okay. Do you notice the pattern? Each time I'm taking 2 of the term prior, and then I'm going to add on 3. So to find a sub 4, I'm going to take 2 of the term prior. So in this case, 25 is the term prior. And then I'm going to add on 3. 2 times 25 is 50. Add on 3, and I get to 53. Same thing for the fifth term. A sub 5 is going to take 2 of the term prior. In this case, the term prior is 53, so I'm going to drop that 53 in there. And then I'm going to add on 3. 2 times 53 is 106. Add on 3, and I get to 109. Okay? So this funky looking notation up here, a sub k plus 1 equals a sub k, 2 times a sub k plus 3. It's just saying take the term prior, multiply it by 2, and then add on 3. Okay, my next 4 terms were 11, 25, 53, and 109. Let's move on to the next set of examples. This E-looking thing is called sigma. It's called a sigma notation. I want to write that in there, sigma notation. It means find the sum. Find the sum. So here, this is saying sigma notation from 1 to 5. I want to take the value of 1, so the first term, all the way up until the value of 5, the fifth term, and add them together. Okay, so I can find all 5 of those terms and add them together, or I can use my calculator, and this time I'm going to use the whole formula. I'm going to find the sum of the sequence expression, comma, variable, comma, lower bound, comma, upper bound. Okay? So I need to go back to my calculator to be able to calculate this. Turn my calculator back on, because I'm sure it's turned off by now. Notice I want to find sum first. So on my calculator, I need to be able to find stat. I hit second stat. And to get to the sum, I need to arrow over to math. Number 5 will give me the sum. So my calculator now says sum of what? Well, I wanted to find the sum of the sequence. So I go back to second stat. This time I'm going to arrow over to ops and go down to number 5 to pick up that word sequence. So now it says the sum of the sequence. Well, what's the sequence? That is this nth term formula here, 2x plus 3. So into my calculator, I'm going to put 2x plus 3, comma, evaluated for the variable x, comma, lower bound and starting at a value of 1, comma, upper bound all the way up until the value of 5. So I'm finding the sum of the sequence, which is 2x plus 3, evaluated at x from the first term all the way into the fifth term. Enter. I get 45. The sum is 45. Okay, bear with me for just a second. If I tell my calculator, okay, so I'm going to grab this and delete the sum here. If I tell my calculator to just find the sequence of this expression 2x plus 3 for x from 1 to 5, it's going to give me the list of those 5 terms, 5, 7, 9, 11, 13. If I add those all up, that's what gives me the sum of 45. Okay, so you can do it by hand, or you can tell your calculator to do the sum and get the 45. Okay, next one. I want the sum starting at the lower bound of 1, going to the upper bound of 10, for this nth term formula, this expression, 1 over n factorial. So again, second stat, arrow over to math, down to number 5 to pick up the sum. Sum of what? We need to tell it to find the sum of the sequence. So second stat, arrow over to ops, and go down to the word sequence. It wants to know what is the sequence now. It's the expression 1 over n factorial. So I'm going to put an x for n, and I'm going to find the factorial sign by hitting the math, arrow over to probability, and the number 4 is that exclamation point that represents factorial. So I'm going to find the sum of the sequence 1 over n factorial, comma, evaluated for x, comma, starting at 1, comma, going all the way until 10. Okay, so it's going to give me the sum. Ooh, 1.7182, blah, 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 blah. Let's see if that turns back into a fraction. Math, number 1, no dice. So I'm just going to round to the hundredths place. The sum is 1.71. Oops, 1.72. I said I was going to round to the hundredths place. Sorry. Okay, next one. Go ahead and try it on your calculator. This time, the lower bound, I'm starting at 5, and the upper bound is 100 for the expression 6n minus 2. Okay, hopefully we got 30,048. Thankfully, we can use our calculator, and we don't have to write out all of those terms, because that's a lot of terms. Starting at the 5th term and going all the way to the 100th term, that would be finding a lot of terms and then adding them together to get to the sum. Using our calculator here, we didn't have to write out those terms. Woohoo! Okay. Moving on. Last example for this section, I want to be able to find the sum from 1 to infinity. Ooh, I can't put infinity into my calculator. Just a second, I have to get rid of this. I don't like it on there. Oh, forget it. Okay, 3 over 10, nope, that should not say squared. That should say I. Change that to the letter I. 3 over 10 to the I, because we're allowing I to start at 1 and go to infinity. I can't put infinity into my calculator as an upper bound here, so I need to just calculate a first, second, third, so on and so forth term to kind of see the pattern that's going on. 3 over 10 to the first power, so I'm finding the first term, a sub 1, so 10 to the first power would give me 3/10. Plus, because the sigma notation means I'm adding, so plus the second term, a sub 2. This time I'm plugging in 2 for I. So 3 over 10 squared is 3 over 100. Plus, find the third term, a sub 3, by plugging in 3 for I. So 3 over 10 to the third power is 3 over 1,000. Hopefully we're kind of recognizing the pattern by now. dot, 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 all the way until we get to infinity, a sub infinity. I want to add all these together and get one number as the sum. Well, looking at this pattern, 3/10, 3/100, 3/1000, next one would be 3/10,000, so on and so forth. I can't really see what's happening, so let's look at the decimals. What is 3 divided by 10? 0.3. Good job, it is 0.3. So 0.3 plus, do you know what 3 divided by 100 is? 0.03. Good job, it is 0.03. Add on, maybe you've noticed the pattern. Can you tell me what 3 divided by 1,000 is without your calculator? 0.003. Fabulous. If we were going to start to add these together and keep adding them, dot, 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 3 plus 0.03 would get me to 0.33. If I add on a 0.003, I would now be at 0.333. If I keep on adding on 0.0003, so on and so forth, I would end up with point and a bunch of 3's after it. Okay. That's the same thing as saying 0.3 repeating, that little bar on the top of the 3. And does anybody know what fraction 0.3 repeating is? 1/3. So the sum, after I add all of these together, the sum is 1/3. Okay, last example here. Use sigma notation to write the sum. Okay, so for each of these, I want to write this sigma-looking thing, sigma notation. So I'm starting at the first term, so I'm going to let n equal 1. If this is my first term, a sub 1, this is my second term, a sub 2, third term, a sub 3, and fourth term, a sub 4. My top bound, my upper bound is 4. So I'm only having 4 terms that I'm adding together here. 1, 2, 3, 4. Total of 4 terms. So I'm starting at 1 and I'm going up to the value of 4. Okay? And that would be the same if my terms were 6 plus 9 plus 15 plus 11. That's still 4 terms. I start at the first term and go to the value of the fourth term. Okay? I need to now write some kind of nth term formula to represent, in terms of n, I plug in 1 and I get out 1. I plug in 2 for the second term and I get out 2. The only thing that's going to represent that is n. I plug in 1 to n, I get out 1. I plug in 2 to n, I get out 2. Okay, so this is my sigma notation. Second one, sigma notation, starting at a first term, so n equals 1, and going to how many terms? Again, I have 1, 2, 3, 4 terms here. So my upper bound is 4. I'm going to start at the first term and go to the fourth term. Okay, here, do you see that we have alternating signs? I have a negative, and then I have a positive, and then I have a negative, and then I have a positive. The way that we represent alternating signs is the number, -1, raised to some power in terms of n. So I'm just going to play with it. Let's let it just be n. Not n plus 1 or n minus 1 or n squared. Just n. Will that give me the alternating terms I'm wanting? If I plug in 1, so a sub 1. I plug in 1 here for n. I get -1 to the first power, which is -1. So I do get that negative symbol. If I plug in 2, a sub 2, I'm hoping to get a positive symbol. If I plug in 2 for n, I'd have -1 squared, which is a positive 1. Okay, so it looks like this is okay. I now need to just figure out what I'm going to multiply this to be able to get the number 1, 1/2, 1/3, and 1/4. I notice that all the numerators are 1. The denominators are changing, though. It would be 1 over n. Because I can plug in 1 for n, and and I would get 1 over 1, which is just 1. I could plug in 2 for n, and I would get 1 over 2, which is 1/2. So on and so forth. Plug in 3, I would get 1/3. Plug in 4, I would get 1/4. This is my sigma notation to represent this sum that is happening over here for these 4 terms. Okay, on the next one, I have 1, 2, 3. Uh-oh, there's a dot, dot, dot. I don't know what term this 1/27th is. So I can go ahead and start my sigma notation. I know that it starts at the first term, so n is 1, but I'm not really sure what this upper bound is yet, because I don't know what this 1/27th term is. I know that the first term, a sub 1, is 3. The second term, a sub 2, is 1/6. The third term, a sub 3, is 1/3. But I don't know what this is. It's a sub something. I don't know what it is yet. Let's look at the pattern. I see that 1 is the numerator for all of them. So I'm going to have 1 in the numerator of my nth term formula that I'm trying to build right here. The denominator has to have an n in it to be able to plug in the value of 1, 2, or 3 and get out 1/3, 1/6, or 1/9. If I plug in 1, I'd have 1 over 1, which is just 1. And that's not what I want. I want 1/3. So let me go ahead and add a 3 here to say 1 over 3n and check it. Now if I plug in 1 for the first term, I have 1 over 3 times 1, which is 1/3. That checks. To find the second term, right here, the second term, which is a 6, I would plug in the value of 2 for n. 1 over 3 times 2 is 1/6. That's what I wanted, so that checks. Does the next one check? If I plug in 3, do I get 1/9? Yes. So what is this term here that I'm looking for? I want it to be 1 over 27. What do I have to plug in for n here in order to get 1 over 27? I need to plug in 9 in order to get 1 over 3 times 9 is 1 over 27. So my upper bound is 9. I'm going through 9 terms for the nth term formula, 1 over 3n. Whoops, didn't mean to cross that out. Sorry. Okay, last example. I'm going to go ahead and give you the summation that starts at 1. We don't know what the upper bound is because we have that dot, dot, dot. So I'm going to let you find the upper bound on your own. I'm going to go ahead and give you the nth term formula. It is -1 raised to the n minus 1 times 1 over n raised to the n minus 1. Okay? So I want you to check this. Okay? Go ahead and find your a sub 1 by plugging in 1. That would give me a -1 raised to the, plugging in 1 for n, so 1 minus 1 times 1 over, plugging in 1 for n, raised to the 1 minus 1. So I just plugged 1 in for all of those n's. I end up with -1 to the 1 minus 1, which is 0 power, times 1 over 1 to the 1 minus 1, which is 0 power. If you don't remember, anything to the 0 power is 1. So -1 to the 0 power is 1. 1 over 1 to the 0 power is 1. 1 times 1 is 1. So that first term of 1 over here, a sub 1, that first term checks. Go ahead and try the second term, a sub 2, by plugging in 2. The third term, a sub 3, by plugging in 3. So on and so forth. And find what term is this. A sub what would give me a -1 over 128, because that's my upper bound here that I need to finish this formula. Okay? That's part of your homework, is find your upper bound, check all of those terms to make sure it's correct, and then you'll get practice writing this nth term formula in this sigma notation in your homework. Homework is listed on your syllabus. Hasta luego.